Yes, indeed. Life will be fun and carefree with a robot. A life without those petty human arguments. A life full of dedicated service to you. But will you be properly prepared for your robot mate? Will you know how to turn on your robot? Will you really appreciate the kind of charge that a robot needs out of life? If not, this series is for you, in shapes, and are called by those of us who are unromantic, batteries. You'll need to know what goes on inside those batteries to understand exactly what gives the robot its energy the instant you need it. Batteries all have one thing in common: a chemical reaction. Oddly enough, this process is similar to another chemical reaction that your robot may be very sensitive to: unsightly rusting. So, just in case your robot contracts a skin condition or a weak heart, let's explore the nature of batteries by first examining a very simple chemical reaction. Consider the element sodium. When oxygen combines with sodium, the process is called oxidation. In this reaction, two sodium atoms each lose one electron to an oxygen atom. The product is sodium oxide. Sodium will also burn in chlorine to form sodium chloride. In this reaction, the sodium atom loses an electron to the chlorine atom. Even though no oxygen is involved, the sodium is still said to have experienced oxidation. Why? Let's compare each of these two reactions by watching a single sodium and a single chlorine atom. Exactly the same thing happens, or ion. So far, we've considered these reactions from the perspective of the sodium's loss. Now, let's look at it from the point of view of other atoms involved. The oxygen atom gains 2 electrons. When chlorine and sodium react, the chlorine gains 1 electron. Reduction is the name given to a process in which an atom gains electrons. In the reactions we have examined, the atoms of one element are oxidized because they lose electrons. These electrons are gained by the atoms of another element, which is being reduced. Without oxidation, reduction is impossible. And so is oxidation impossible if there is no reduction. Since oxidation and reduction must occur simultaneously, these reactions are called redox reactions. All redox reactions are like this one. One atom is reduced, so the culprit that causes it to happen is called a reducing agent. Looking at it the opposite way, the sodium is oxidized. So the perpetrator that causes the oxidation, the chlorine atom, is called an oxidizing agent. If this seems confusing, consider the situation in which a police car is chasing a car thief. The thief may also be called the police evader, and the police may be called the thief chaser. In the same way, the oxidized substance is also the reducing agent. And the reduced substance is also the oxidizing agent. So finally, let's get back to your handsome but middle-aged robot with embarrassing rust and a weak heart. As we noted before, a battery, or more properly, an electrochemical cell, somehow produces a flow of electrons in the circuitry connected to it. If we examine it more closely, we see that it has two electrodes, which are good conductors of electricity. At the negative electrode, electrons are flowing into the attached circuit. This means that something is being oxidized here because something is losing electrons. In an electrochemical cell, the anode is the name given to the negative terminal at which oxidation occurs. Similarly, at the positive electrode, we can see that electrons are entering. Since something is accepting electrons, reduction must be occurring. Cathode is the name given to the electrode at which reduction occurs. The material between the electrodes, called the electrolyte, contains ions which conduct electricity. Cations migrate towards the cathode. And when we look closely at the cathode, sure enough, some of the cations are gaining electrons and being reduced to atoms. The negative ions in the electrolyte are called anions. Anions migrate towards the anode. When we look closely at the anode, we might expect to see the opposite of what's happening at the cathode. In other words, anions becoming oxidized and losing an electron. As neat and reasonable as it might seem, this is not what happens. Instead, another reaction takes place which involves the atoms of the anode. It is these atoms which undergo the oxidation, not the anions in the electrolyte. The atoms give up the electrons to the anode and become ions, which begin to migrate away through the electrolyte. So why do anions migrate to the anode? And even more curious, if we look at what's happening to the cell as a whole, it seems as if positives are being attracted to positive, and negatives are being attracted to negative. In all our past experience, we have been taught that opposite charges attract each other. There, that looks more reasonable. That an electrochemical cell doesn't work this way. For some reason, the positive ions do migrate to the positive terminal, and the negative ions to the negative terminal. There is obviously a little more to the electrochemical cell than meets the eye. The heart of a robot is still a twist and a turn away. We'll need to make some sense of all these migrating flocks of positives and negatives before we can really understand how to charge up a robot. If you can't do it yourself, you'll need our next chapter.